fellow judges. My name is Alessandra da Silva,
And my name is Nicola Madu.
and we're from Willow International School, Costa do Sol, Mozambique, and we're in grade 11. And our project is about zero-cost water purifier. And you may be wondering, why a water purifier?
This is all about saving the aquatic life. As we know, aquatic ecosystems support various life forms, and the discharge of contaminants is a matter of concern all over the world. Thus, the water released should be purified at source. This project aims to clean wastewater by flowing through different layers of corn cobs, like long pieces of corn cobs, short pieces of corn cobs, activated charcoal made from corn cobs, and fine sand. This is a cost-effective and simple technique, and it is used for immobilizing contaminants in industrial and domestic effluents in ponds, reservoirs, and water tanks. This project aims to clean wastewater without spending money by using corn cobs. That's why it's titled a zero-cost water purifier. The materials used in this project were 5 kilograms of corn cobs, 6 empty Coca-Cola bottles, a 5-liter water bottle, a balance, an iron stand, filter paper, 1 kilogram of white sand, plastic pipe, and a plastic band.
This project follows the following procedure. First, we collected the corn cobs from local farmers and we sun-dried them for 15 days, and then we smashed the corn cobs into different sizes. After that, we took 1 kilogram of corn cobs and blended and powdered them. After that, then we took the corn cobs and put them into 5 separate bottles of 5-liter water bottle. In the first bottle, we took 400 grams of dried longitudinal sections of corn cobs, which means they are bigger in size. In the second bottle, we took dried small pieces of corn cobs. The third bottle, we took 400 grams of powdered corn cobs. And in the fifth bottle, we took 500 grams of fine sand, which is the last layer. At the bottom, we kept a 5-liter water bottle to collect the filtered water, and at the top, we kept 5 separate 2-liter water bottles filled with pond water so that we could filtrate it. After that, the filtered water was collected and tested for the absence and presence of chemicals mentioned below.
Finally, the results of the chemical analysis that were presented in the first and second table showed the presence and absence of contaminants in industrial and domestic effluents before and after the treatment. And we also concluded that waste such as magnesium salts, calcium salts, copper, lead, strontium, chromium, detergents, gasoline waste, suspended dyed colored particles, and colored dyes were all found present before the treatment, and after the treatment they were all absent.
There is a question proposal. Maize is the common name for the cereal grass that is widely grown for its staple food and livestock fodder. Corn is the third most important root cereal grass in the world after wheat and rice. All the parts of the maize plants are used for various purposes, but however, corn cobs are one of the most plentiful and important agricultural wastes in maize cultivation. Immature corn cobs are boiled and eaten by local farmers, but mature corn cobs are used for fuel, which can cause global warming and air pollution. A fun fact is that corn cobs are not even eaten by animals, as they might choke their digestive tract and lead to death. So, many corn cobs are found in places where they're cultivated, dumped in random places. In our analysis, we also noticed that the colored substances present in the effluent water were absorbed by the charcoal layers. The suspended particles were absorbed in the chaff layers, both long sections and small sections of corn cobs, and the maximum absorption of the gasoline waste was found in the powdered corn cob layers. The rate of absorption was proportional to the rate of the surface of the corn cobs.
And finally, the results of the chemical analysis that were presented in the first and second table showed the presence and absence of contaminants in both domestic and industrial effluents before and after the treatment.
Yes, and in our report, we could conclude that corn cobs were a suitable absorbent because of their mechanical strength, rigidity, and their porosity. And for you to not be confused, we also have some 10 advantages of our project, which are:
it is simple, eco-friendly, which means that it does not damage the environment. It uses no uses no maintenance, uses cheap technology, and it is not edible.
It is cost effective, it is locally available, easy to use, and an agricultural waste, which means it will help everybody in our world. Thank you.
Thank you.